So the last topic will be spatial analysis, and we really began to see some of the power of GIS and databases when we began to do some attribute queries and summaries last week, looking at the categorical and the quantitative maps. So just a couple things to review. When you get that red exclamation point, what does that mean? So what it means is that the map document cannot find or read your data, doesn't know where the data is, or can't read it for some reason. One reason could be that you have not actually uncompressed the folder. So you can open your ArcMap document, you can open a Word document that's still in a zipped or compressed folder, but the ArcMap document, the MXD, will not read your data. So you need to make sure you unzip that. If you're still getting those red exclamation points, then you're going to need to do the process we did in the second lab with ArcGIS, where you right-clicked and you navigated to the data folder. Okay, so with geoprocessing, one of the things that's very different with this is with as we go through the different geoprocessing tools, every time you do that, you're going to create a new data set. So when we were selecting data and summarizing data, we created a new table, perhaps, when we summarized it, but we didn't create new data. And this time we will be creating a subset of the data when we do an attribute query. And then around that subset, we're going to do some other processing steps, and each one of those processing steps results in the creation of an entirely new and separate feature class. In this case, we'll be creating separate shapefiles. So there's several different processing steps that we can do. A very common one is the buffer. Then we're going to look at some intersects and some unions, and dissolve is a pretty handy tool as well. So one reason that you work with spatial analysis is to make decisions, to predict the future, understand past events, and as I said earlier, this is the real power of geoprocessing or GIS. And you want to really look at the characteristics of the features based on their relationship to other features when you're doing these combinations. There's a story of a gentleman named John Snow, who was an anesthesiologist, I believe, in England during the 1800s, and there was an outbreak of cholera, and the belief at the time was that people got cholera from bad air, and so the remedy was to close the windows and stay inside and don't shower. But he decided to try and understand why people were dying, and he wanted to look at it spatially. And so he began to create a dot map that looked at where people died and where they worked. And what he noticed that there was a high concentration of deaths in this one specific area. And on further analysis, he realized that the thing that people had in common was that they were going to a certain water pump. So he had the city close off that water pump, and the incident of cholera cleared up. And that was one of the first documented cases of spatial analysis in an applied way. So when we do our projects, or this next lab, we're going to be doing some attribute queries, and we did this in the qualitative mapping as well. But we're going to select things based on specific field attributes. So you could select things like from a feature class called states, and you're looking at the population field for people with a population of over 100,000. Or you might look at a city named Springfield, and a city named with a population. So you want to find all the Springfields with a population over 50,000 of that value. So you kind of get the idea of how these queries work. So when you want to select by one attribute, this is what we did before, and you guys in this next lab, you're going to select some schools based on a type of school. So here's an example. The layer we're selecting from is Lane Schools, and you want to select a type that's equal to type 1, and you choose OK, and it gives you just those selected features. But you could also select by, if you want to pick out 5 schools with specific names. So in this example, it's selecting from the Lane Elementary Schools, and the field is school name. So its school name is equal to, and then under unique values, you choose the school name, so Howard, and then you choose or school name equals this, or school name equals, and you can just keep doing school name equals a school name, and then the operator or. Now you're choosing the or operator when you want to select multiple features. The and operator is what people instinctively want to use, but if I chose the and operator, I would have to have, if I said, for instance, school name equals Howard and school name equals Maple, the school name would actually have to have both of those things in it. So I'm saying pick from this or from that or from that. I'm indicating that the field name does not have to have both names in it. So I'm just looking at all the different options in the field name. So those are attribute queries. Another type of query that you can do is called a spatial query, where you select one feature based on its relationship to another feature. So I could find all the liquor stores that are within 500 feet of a school, or all of the rivers that intersect a road, or all of the schools that are totally inside Lane County. So this is a different type of operation, and I'm not looking at the name of any of the attributes within that field, but I'm looking at all of the attributes in one field with respect to another field. So to select by location, it's addressed in the same way, where you go to the top of the map and you do select, and instead, or the top of ArcMap, and instead of select, choosing select by attribute, you would choose select by location. And for example, I want to select all of the schools that are within 20,000 feet of Lane County. So that would be all of the schools in Lane County. That's not a great example, so I'll show you some other examples in a little bit. So this this query was saying all of the schools that are I know what I did. Okay, so this is kind of a double query. So I selected all of the schools in a certain area, and then from those schools which were already selected, I selected the other ones. I used the location query and said, now that you have all the schools selected, just select the schools that are within 50 feet of a water surface, or 50 yards of a water surface. And so you see that it didn't select all of the schools again this time, only the ones that were within a certain distance of that parameter. Now, one of the things that you can do with the attribute query or the spatial query is to take those features that are selected and save them as a new shapefile, a new separate feature class. And so while I have these selected, I can go to the data and say export these selected features and name them schools in Lane County, or schools near water, whatever, and we'll demo that in the lab as well. Um, there are several operators that you can use. Equals, so state equals Oregon. So if you look down all of the states, you're looking for just the name of a state, that's Oregon. If I'm looking in the age category, I want all of the states maybe that have an average age greater than 40. So that will take 41 and above. If I say average age less than 40, it will take all of the states where the average age is 39 and below. If I want to include 40, I need to add that, greater than or equal to 40 or less than or equal to 40. And here are some operators that let you find all of the ages that are less than and greater than, but do not include 40, so it would eliminate 40. So those are the two kind of queries, spatial query, attribute query. The other operator we're going to use is the buffer. And a buffer creates a polygon of a set distance, whatever distance you choose, around a point or along a line or around the edges of a polygon. And so I selected out 4 schools, and I created a 1 mile buffer around the 4 schools that were selected, and those buffers are separate. So I have a feature class that is composed of 4 separate 1 mile circles. And the idea of buffers are pretty common. When the earthquake in Japan several years ago, they created circular buffers around the Fukushima power plant to kind of delineate the different distances that were in danger of 20 kilometers, 30 kilometers, 80 kilometers. So you see buffers used all the time, sometimes effectively, sometimes not very effectively. This is a kind of bad use of, I don't know if it's bad use of buffers or a bad use of mapping, but you've got a bunch of circles drawn around this little nuclear power plant symbol, and yellows are decommissioned and red are in service, and they overlap. I don't know what it's trying to tell me, and I don't know how big the buffer is, and why are they using a buffer anyway. It's supposed to give me, I think they're trying to tell me there's like an influence or danger around there, but they don't really say that. So you have to have a reason for the distance of the buffer that you're using. Another operator you can use is the dissolve, and the dissolve combines polygons that have the same feature type together. So if I had counties, and I had counties in Oregon, counties, the purple are counties in Washington, and I don't know that we would ever have that configuration. I'm trying to see where this might be. Maybe it's vegetation types. Let's do that. So the blue is a pine, and the green is a fir, and the purple is agricultural land. And so I've got these categories of land types, but I don't want that many polygons, so I can join them or dissolve them on the same field. So all of the pine polygons that touch each other will be merged into one. So you can kind of simplify your data that way. So that's a dissolve. An overlay or an intersect is a process that takes 2 different layers of data, 2 polygon layers, and gives you a new feature class based on where the 2 layers overlap, and ignores where the layers do not overlap. So I've got these 2, maybe this is land use, and the blue means urban land area, and then the circle is an area of I don't know, soil contamination. So if I intersect or overlay these 2, I get a polygon that shows what the land use is and where the contamination was. So one of the things that you're going to do in this lab is to create a 1 mile buffer around a school. And then using that buffer, you're going to intersect with the census data. And what you're going to end up with is specific census blocks, giving you the number of people in each block that are within a 1 mile distance of a school. And then the last type of geoprocessing that you can do is called an overlay with symmetrical difference. And so this kind of actually is almost an erase. It cuts out where the two polygons have in common. And in 245 we do a lot more of these kinds of operations, but this lab that we're going to do today is just doing some selecting, doing some saving, and just looking at the different options with geoprocessing.